Let us prove this statement by mathematical induction. It says we should prove the sum from r equals 1 to n of r minus 1 equals n squared minus 1 over 3, as you see here. Now, just a reminder, when we prove by mathematical induction, we have certain steps. In step 1, you show that the statement involving 1 is true. So you say P, proposition P1 is true. So you start off right from the first step. Now, let's do that and see what happens. So in this case, we say that if P1 is true, show that P1 is true. And you should write that statement that you're showing that P1 is true. It's part of your working. So you let R be equal to 1. If you do that, you get 1 minus 1 equals, well, when R is 1, since it's only 1 alone, n will be 1, 2. So it's 1 squared minus 1 over 3. So in this case now, you would have 1 minus 1 is 0. 0 times 1 is 0 equal, and then 1 squared is 1, 1 minus 1 is 0, 1 times 0 is 0, 0 over 3 is 0. Right? So these are 0. See that? Now the next thing you do, step 2, what you do in step 2 is to assume that P K is true. Now, K can be any number. The thing is, if you show that P1 is true and then that P2 is true, I can always say, alright, what about P3? If you show that P1 is true and P2 is true and P3 is true, then I say, what about P4? Now, if you show that P10 is true, I can always ask you, what about P9 and P11? What about the number before it and the number after it, right? But the thing is, I don't know what K is, so I can't make that argument. You assume that PK is true, and it is an assumption, because you don't know yet. Alright? So, the next step, you assume that PK is true. So when you do that, what you're going to write, I don't want to scroll too far away from this. I want to keep seeing it. So if you're writing notes, you can just pause the video and write the notes. But let me just erase what I have up here. Get it out of the way. You know that this part is necessary. And you have to show this part in your working. Now let's just erase this. And put this up here, you assume that pk is true. Now, here, remember, what you have up here is the base case. We call this the base case that you show that P1 is true. And then when you assume, it's an assumption, it's a hypothesis. So this is called the induction hypothesis, right? That's where we are now. We assume that pk is true. If we assume that pk is true, what we have to do is change n to k. Alright? So we write the sum from r equal 1 to k of r minus 1 equal k squared minus 1 over 3. That's what we do there. Now remember, we don't change r, you know, because look at this. If we have the first two situations where r is 1 and then r is 2, what we would have is r is 1 times 1 minus 1, that's the first case, plus when r is 2 is 2 minus 1, and that means when we add from r equal 1 to 2, n would be 2, so it's 2 squared minus 1 over 3, right? That's what happens here. So we have 0 plus 2 minus 1 is 2, 2 1 is 2 equal 2 squared is 4, 4 minus 1 is going to be 2 squared is 4, 4 minus 1 is 3, 3 2 6 over 3 is 2, right? And so we don't change 2. If we should go to the third one, what we would say is that r is 1, then r is 2, then r is 3. So we have 3 minus 1. So it's 3 plus 3 minus 1 equal, and then n is 3. We change n to 3. We don't rewrite r. We keep r as it is here. It's n alone we change to k. When we reach 3, r becomes 3, so we change n to 3. So it's 3 squared minus 1 over 3. So what we have, this is 0 plus 2 minus 1 is 2, 2 1 is 2 plus 3 minus 1 is 2, 2 3 6. So this part would be 8, and then this is equal to 3 times 3 squared is 9, 9 minus 1 is 8 over 3, 3 cancel 3 is 8, and so on and so forth. So here, when you have this case where you're summing values, remember, in the first, r is 1, but n is 1, because it's just one of them. If you're summing the first and second, r is 1, then r becomes 2. But from 1 to 2, n becomes 2. If you're summing up to 3, from r equal 1 to 3, you don't change r to 3. You keep r, because in r equal 1, r is 1. Then 2, r is 2. Then 3, r is 3. But n doesn't keep changing from 1 to 2 to 3 and so on. When you sum from r equal 1 to 3, n becomes 3, so you change this to 3. And so on and so forth, right? So when you say pk is true, you say r equal 1 to k. So the sum from r equal 1 to k of r minus 1 equals, and then n becomes k squared minus 1 over 3. You see that? All right. Now, after that now, you go to the third step. So, step 3, you prove that. Now, what is it that you're going to prove? Now, remember, you started by showing that the statement is true at the start when r equals 1. Good. You start off right from the first step. Then you assume that pk is true. You don't specify any number, right? K is not any specific number. So you will assume that pk is true. The next thing now is that if you say to me that you assume that pk is true, then I would say, all right, even if you should assume that pk is true, and I don't know what k is, the problem is, what about the next number after it? All right, so that is where you're going to prove that. What's the next number after k? The next number after k is k plus 1. So you prove that pk plus 1 is true. All right, that's the next thing. Now remember, in working it out, you must show this. I'm going to erase it because I don't want to run out of scrolling space and I don't want to stray too far from this step. I have to be scrolling back and forth every time. So let me erase this part. And then the next step in solving it is to say, proving that p of k plus 1 is true. So you have to change n to k plus 1. All right. So now it means that you're summing up from r equals 1 to k plus 1 of r minus 1 equals n changes to k plus 1. So this n will come here and become k plus 1. Open bracket. Now this n squared will become k plus 1 squared, since n becomes k plus 1. This will become k plus 1 squared. And then we have our minus 1 here. Minus 1, close the bracket, all over 3. So you see that? All right. Now, you see this part? What you have to do is break it up into the sum. All right, let me write it out, into the sum from 1 to k, then add k plus 1. That's what you're going to do. Now, you're going to say this is sum from r equal 1 to k. So it's going to be the sum from r equal 1 to k of r minus 1, plus what? The k plus 1's term. All right? Now, let me look at this. What is the first term? The first term is 1, 1 minus 1, right? What's the second term? The second term is 2, 2 minus 1. Alright? Looking at this, you know. What is the third term? The third term is 3, 3 minus 1, right? What is the kth term? The kth term is k minus 1. So what is the k plus 1th term? Well, I jump up here, man. The k plus 1th term is going to be this. K will become k plus 1, so it's k plus 1 times open bracket. This k becomes k plus 1 too. So it's k plus 1 minus 1 in the bracket. See that? Alright. And that will be equal to. Now, let's see something else here. You might be saying, how is it that you break this up into 1 to k? Alright, suppose I have the sum from r equal 1 to 5. Alright? Now, I would be saying this is equal to the sum from r equal 1 to 4 plus the fifth term. See that? It's like I'm saying 1 plus 2 plus 3 plus 4. This is the sum from r equal 1 to 4, you know. But I'm not finished. I have one more plus the fifth term. It's the same argument here in saying that I break up r equal 1 to k plus 1 into sum from r equal 1 to k plus the k plus 1th term. Same argument. You see that? Alright, so this here is the k plus 1, whatever it is, term. Alright? Now this is equal to, alright, k plus 1. So we have k plus 1, open bracket. Alright, we have two round brackets here. Let me change this one to a square bracket, so that's not to mix them up. Square, open square bracket, k plus 1 squared. So this is k plus 1 squared minus 1, close bracket over 3. Minus 1, close bracket over 3. Alright. Now what's going to happen here? Look at this. From r equal 1 to k of r minus 1. This looks like r equal 1 to n of r minus 1. It was n squared minus 1 over 3. So if we're going from r equal 1 to k, this would be k squared minus 1 over 3. So it's k squared minus 1 over 3. So this would be k squared minus 1 over 3. Right? That's this part. That's it. Plus, alright, let's write this k plus 1 times, but hold on, this is k plus 1 minus 1, close bracket. But 1 minus 1 is 0. This is 0. So I can erase it. This is 1 minus 1. And this here is k. Let me put the bracket nearer. But we don't need the bracket. Can just get rid of the brackets. Right? And then what we have here is k plus 1 times k. We could write the k in front. Let's move the plus and then move the k in front here. Right. So what we have is k squared minus 1 over 3 plus k times k plus 1. You see that? Move the one a bit away, give it some space. Alright, so that's equal to what now? What we have here is k plus 1 times k plus 1 squared. So it's k plus 1 squared. What was out here? Minus 1 and close the bracket. Minus 1 and close the bracket. All of this over 3. So you see that? Suppose we multiply what this k plus 1 squared business here. What would happen? Let me give some space to it and see what's going to happen here. K plus 1 squared is really k plus 1 times k plus 1. Alright? So let's see what happens here. We have k plus 1 times k squared, k times k squared, k times 1 plus 1k plus 1 times k. It's plus 1k plus 1 times 1 is 1. Then minus 1 all over 3. You see that? But hold on. 1 minus 1 is 0, you know? So we don't need this. This is gone. It's plus 0. Oh, and guess what? Look at this. K plus k is 2k. So we just write 2k here instead. Plus 2k. Right? And put this bracket nearer. Alright. So that's what we have there. Now, what do we have on the left hand side again? Alright. Now, what we want to do is simplify and make it clear that the left hand side and the right hand side are equal to each other. Now, of course, we could very well change up both of them at the same time and simplify. We could multiply by 3 and multiply out the brackets. But the more sophisticated way of showing it is to change only one side. We could change up the left hand side and make it look like the right hand side, or we could change up the right hand side and make it look like the left hand side. Let's see. It seemed like it would be easier to change the left hand side to make it look like the right hand side. Alright? So, let's do that. See what will happen. Alright? Suppose we use common denominators. So we multiply the left hand, this part, by 3 over 3. Let's rewrite this part. K squared minus 1 over 3 plus, multiply both top and bottom of this by 3, 3k, k plus 1 over 3 by 1, because this is over 1, you know. Alright. But 3 by 1 is 3, so this amounts to 3. Now, you remember that when we have an expression divided by 3 plus another expression divided by 3, we just put everything over 3 and just add the top. So it's k squared minus 1 plus 3k, k plus 1 up top, equal that. Alright? Now, you see this? It's a difference of 2 squares. It's factorization of a difference of 2 squares. You could have k and then k plus 1 times k minus 1. If you multiply k plus 1 by k minus 1, you get k squared minus 1, right? Remember that? The difference of 2 squares. plus 3k, k plus 1 over 3 equal the right hand side. Don't want to keep on having to write down the right hand side every time. I'm going to write it eventually. Alright, but I'm working on changing up the left hand side. Okay, look at this. The k plus 1. You see the open bracket k plus 1 here, close bracket, and you see an open bracket k plus 1 here, close bracket. You see that? We could factor it out. So we factorize. What we have is k plus 1, and then let's use a square bracket here. What you have inside the bracket, we have the k will come here. It's k times the k minus 1 in bracket, k minus 1 plus, and then we have 3k close bracket, square bracket I'm using, equal. And remember, let's put this over 3. So we have that, alright? Now, what else can we do here? Suppose we multiply out the k by the bracket. What we have is k plus 1 times k squared minus k. See that? We multiply k by what is in the bracket. Plus 3k. And then this, oh, we run out of scrolling space, but anyway, over 3 equal the right hand side. This is something here. Negative k is negative 1k, but negative 1k plus 2 plus 3k is 2k. So this is really 2k. Let's write this as plus 2k. Alright. And draw the bracket nearer. Alright, so this is what we have. What was the right hand side about again? Let's write it. K plus 1 in bracket. It was k plus 1 in bracket. K squared plus 2k. And we have k squared plus 2k over 3. Alright. So let's compare. K plus 1, k squared plus 2k over 3. Ah, good, good. So once you reach here, you write proved. That you proved it. Good. Alright, so what I want you to do, your homework, is to write this down. And then on a clean sheet of paper, make an attempt at it. Try it. And until you get it right. Alright, so I'll see you in the next video.